Hello, good people. We're going to talk about a data structure known as an array. Data structures in general allow you as the programmer to address multiple data elements as a single collection. And this is as opposed to naming multiple data elements individually. So in the case of our eggs here, rather than declaring egg 1, egg 2, egg 3, a data structure in most cases allows us to call a collection of data elements by a single name. These structures can be defined usually with a specific size, and then we can modify that size within the operation of the program to accommodate differing needs. So in this case we may start out with a dozen eggs and later decide to package 18 eggs together, or show at some point in our program that we have 0 eggs. Now, if we didn't have this structure, this collection, we would have to have 12 different variables, egg 1, egg 2, egg 3, and so on. And if we changed the requirement, we would have to have egg 1 through egg 18. And that would be a lot more work. So this data collection or data structure idea helps us to get past that problem. An array is a data structure, a collection of a fixed number of data elements, and each of those data elements is of the same type. The declaration for an array starts out like most variables that you've declared, starts out with a specific data type, in this case integer, and then an identifier that the array will be known as, and then within the square brackets the size of that array. So in the case of the example you see before you, we are going to create an array of integers. It will be known by the identifier test scores, and it will contain 10 integers. So as we lay this out in our mind as we're looking at this, once the array is declared, we can address this collection by its identifier test scores, and then address each of the test scores individually within that array. So I have one student's pretty good record of test scores here, and you see the first test score would be 90, the final test score was an 84, and we can address the first, last, and any of these in between. When your compiler creates an array, what it does is go out and look in memory for enough contiguous memory space to set 10, in this case integers, side by side. And it allocates that space, and it assigns that space to the identifier that you gave, in our case test scores. If we want to address the individual test scores, we do so by using something called an index or a subscript. In the case of a C++ array, we always start counting from 0, and so my first test score is identified as test scores 0. The 100 would be test scores 1. The final score that the student received would be test scores 9. Here's a little code snippet that shows us this simple array in action. You see that we have declared the array integer test scores, given it a size of 10. I'm going to use a for loop because it's a counter-controlled loop and it's easy to address each of the individual elements. And I'm going to use it first to input the data from the keyboard. So the user will enter this for loop and they will receive the prompt enter test scores, and it'll actually say on the screen enter test score 1, and the user would type in whatever the score was, and the program is then going to assign that input value to the test scores. Once the user has entered the test scores, We can use that same for loop structure to output the test scores. Instead of using cin, we just use cout. We address each of the subscripts of the array individually, and one by one each of those scores is sent out to the output screen. It's important to remember that with an array in C++, we have to define the size of the array at compile time. There is another type of an array called a dynamic array, but we won't encounter that just yet. So for our purposes, each of the arrays that you use must be pre-declared at compile time, and the compiler has to know the exact size that the array is to be. So in this case, we see an integer scores 5. That 5 tells it how much space to allocate. A better way of doing this would be to declare a constant, assign a value to your constant, and then use the constant when you are addressing either the size or the subscripts of your array. If you try to set the array size through a variable, your compiler is going to spit out an error message. It will not allow you to declare a variable, in this case called students, and then you assign a value to it, or you ask the user to input that value, and then you pass that to your array declaration. That can only be done with a dynamic array, and we won't be working with those just yet. You are also responsible for all boundary checking on the arrays that you declare. Now, C++ and C before it are famous for allowing you to do exactly what you feel like you need to do within your program, and that includes writing past the end of your array. If, for example, you declare an array called test scores and give it a size of 10 integers, 10 integers worth of space is allocated within the program. But C++ will allow you to pass a subscript value that is greater or less than the boundary values of your array. So you could say cout test scores 12, and through the mechanism by which C++ handles arrays, it will go out 2 more integer spaces past the end of your array and pick up whatever value is sitting in memory, which could be garbage, it could be a valid integer. You won't know. But your program will dutifully pick it up and write it out, or use it in a computation, which would be even worse. So in your program, you must ensure that you do not write below the 0 subscript or pass the maximum subscript, because if you do, you're going to bring problems upon yourself within your program. You also need to make sure that your array is initialized. Just like we initialize all variables to a single value, when you initialize an array, you need to set all of the subscript locations to the predetermined value. Now, I've got a couple of different ways showing in front of you. At the bottom is the most common way that you're going to handle things. You're going to say, in this case, we're going to store an array of doubles. And at each of the locations, we're going to write the value 0. So we put that within curly braces, and that says to the compiler, fill every element, every subscript location with a 0. In the case of temperatures above, I have specified most of the temperatures. The remaining values will get set to 0. So at subscript 0 we get 90, subscript 1 we get 91, and so on across there until it runs out of values, and then it will fill the other values with 0. Here's a sample program along the lines of what we saw in the examples. You can see that we have declared a constant called array size, and I've assigned that a size of 5. That allows me to easily manipulate the size of the array by simply changing this from 5 to 15. I've expanded the size of my array. Here's where I declare the array itself. I've given it a data type of integer, an identifier called test array, and then I use the constant to declare the array size. If you remember, this 0 inside of the curly braces is initializing each one of the subscripts, and it does that at the time that the array is allocated. All right, in the first for loop, I'm going to fill the array with user input. So I set it up inside of a loop controlled by the array constant again, and this will just ask me a series of questions. My cin statement, rather than sending it to a variable, I'm sending it straight to the array, and it's going to place it at the subscript that is assigned by the for loop. As soon as I have filled the array, this example will output the array. So again, I set up another for loop, and it will display each of the individual elements. So this gives you all the basics of using an array: inputting values, outputting values, and if you know how to output values, you also know how to take those values and use them in calculations or other manipulations. So let's execute this program. And you see that it doesn't really do anything earth-shaking. We'll put in a few numbers here. And it does nothing but send these back out to the screen. Arrays are like any other data element within your program, and they can be passed as parameters to function, but functions cannot return a type of array. So you cannot write a function that returns an array. The reason for this is that arrays are always passed by reference. If you remember the difference between reference and value parameters copy the value into the function. The function operates then on a new data element, not affecting the original data element. And when we pass something by reference, you're passing the address of the variable location, so that when your function is operating upon a reference parameter, it is actually operating upon the original data element. In the case of an array, the program does not want to copy a large data structure, make another copy of it, pass all that data into the copy, operate upon the copy, clean up the copy, and then go back to the original, because that would just be too costly in terms of performance. So arrays are always passed into your functions via the reference mechanism. So the address of your original array is passed in the parameter, and so when your function is working upon an array, it's working upon your original array, and that's important to remember. When you are writing a function parameter, there is a really kind of simple difference that you have to keep in mind. When you write the declaration or your prototype, you're going to declare the parameter much like you would an array variable that you create in main, for example. So as you see in this example, we have function name, and we're going to pass an array of integers. We don't pass the size within the brackets, but the brackets tell the compiler that you're passing an array, and that automatically makes it a reference parameter. When you go to call the function, so actually use it within your program, all you pass is the name of the array. And this works through the pointer mechanism that we'll learn about later. So you call the array, and you don't pass score array with brackets around it or anything like that. You just simply give the identifier that you have assigned to your array, and then the compiler will take care of making sure that the address gets passed in, and then your function can operate upon the original array. To our original program, we've added a little modification to show how to utilize an array with a function. Remember that your functions cannot return a type of array, but they can accept an array as a parameter. Also remember that your arrays are being passed via reference, and with this example that'll make a little bit more sense. So to our original example where we have collected user data, we're going to call a function that finds the largest number that the user enters there. So I have declared up here my prototype for find large. I'm going to return a type of integer, and I'm going to pass in the array of values that the user input at the screen. You see in my prototype and in my function signature down here, I have a parameter name in array, and I pass the square brackets. The square brackets are empty, and that simply tells the compiler that it's receiving a parameter of type array. Down where my function declaration is, you see the same signature. And I operate upon not the original array name, but through the parameter name. So now my array that I originally created is now going to be known as inArray. And so in this case, I'm simply going to walk through a loop and find the largest value that is contained within that loop, and then return it. When I call the function, the syntax is a little bit different. Here's where I'm going to output what the largest value is, and I call my function right here, find large, but I don't use the square brackets now. I simply pass the identifier of the array. So my array is test array. I pass that identifier to the function. Now what's going to happen when this program is executed is that the program will allocate enough space for 5 integers and set up the array for me. When I work upon it here, it's going to place those integers into the various subscripts as assigned by the loop. And then when I call this function, it is going to take this array identifier, and it's going to pass the address of that array into my function. So this function is operating upon the original array. So any modifications that I might make in here, any changes that I make, will be passed back to the original function. So keep that in mind. Let's execute the program. And same thing. Put some numbers in here. And press enter, and we see that the largest value that was entered is 789.
Well, thanks for watching. I hope this has been helpful for you. Single dimensional arrays are used quite a bit in our coursework and in general programming. We're also going to encounter arrays that have multiple dimensions. They have both an X and a Y axis, but we won't come to that for just a bit yet. As always, if you have questions, you can email me, or you can post a question in the student questions forum, and either myself or one of your fellow students will help you out. Have a good day. Good luck on your program this week.